346 people died. Not because of a storm. Not because of an engine failure. But because of a decision. Every time you step onto an airplane, you are performing an act of ultimate trust. You trust the pilot, the mechanics, and the air traffic controllers. But most of all, you are trusting a group of people you will never meet. The engineers. You trust that when they sat at their desks, they weren't just thinking about aerodynamics or fuel efficiency. You trust that they were thinking about you. But what happens when the pressure to succeed, to compete, and to profit begins to weigh heavier than the responsibility to protect? The story of the Boeing 737 MAX isn't just a story about a plane. It's a story about the invisible weight of a signature and the thin line between a brilliant solution and a fatal compromise. To understand how we got here, we have to look at the War of the Skies. For decades, two giants have battled for control of the air, Boeing and Airbus. In 2011, Airbus was winning. They announced a new, more fuel-efficient version of their most popular jet, the A320. Airlines went crazy for it. Boeing was caught off guard. They needed an answer, and they needed it fast. They had two choices: design a brand new plane from scratch, which would take a decade and billions of dollars, or update their workhorse, the 737. They chose the shortcut. They decided to put new, massive, fuel-efficient engines on the existing 737 frame. But there was a problem. The 737 sits very low to the ground. These new engines were so big they wouldn't fit under the wings. So, engineers moved the engines further forward and higher up. It worked, but it changed the physics of how the plane flew. Under certain conditions, that new engine placement caused the nose of the plane to pitch upward. And in aviation, if the nose goes too high, the plane stalls and falls out of the sky. To fix this hardware problem, Boeing created a software solution. It was called MCAS. Think of MCAS like a hidden hand. Its only job was to monitor the nose of the plane. If it sensed the nose was getting too high, it would automatically push the nose back down. And this is where everything starts to go wrong. On paper, it was clever. It made the new heavy-engine plane feel exactly like the old version to the pilots. But there was a catch. Boeing wanted to market the MAX as a plane that required zero expensive simulator training for pilots. If the pilots didn't need to learn a complex new system, airlines would save millions. So, to keep things simple, Boeing didn't just make MCAS a background system. They didn't even mention it in the pilot's manual. Most pilots around the world took to the skies in a multi-million-dollar machine, unaware that there was a powerful software ghost in the cockpit with them, capable of taking control of the aircraft. This is where the engineering shifts from math to morality. As the MAX moved through development, red flags began to appear. Internal documents later revealed that some engineers were concerned. They saw that the system relied on a single sensor, a tiny vane on the outside of the plane. If that one sensor failed or got hit by a bird, MCAS would think the plane was stalling when it wasn't. It would start pushing the nose down, over and over, fighting the pilot for control. Imagine you're riding a bicycle, and a hidden motor suddenly jerks your handlebars toward the ground. You pull back, but 5 seconds later, it jerks them down again. You don't know why it's happening, and there's no manual to tell you how to turn the motor off. The engineers at Boeing are some of the smartest people on the planet. They knew that single points of failure are the cardinal sin of aviation. Usually you have backups for your backups. But the pressure to keep the project on schedule and avoid costly training was immense. It wasn't a math error. It was a series of choices. In a high-pressure corporate environment, the right decision isn't always the loud one. It's often the quiet one. It's the decision to say, this isn't ready, even when it costs the company millions. It's the decision to demand that pilots be informed, even if it makes the product less competitive. In the case of the 737 MAX, the no wasn't loud enough. The system was pushed through. The planes were delivered. The marketing worked. And for a while, everything seemed fine. Until October 2018. Lion Air Flight 610 took off from Jakarta. Shortly after takeoff, a faulty sensor triggered MCAS. The software began a tug-of-war with the pilots, nosediving the plane more than 20 times. The pilots fought until the very end, but they didn't even know the system they were fighting existed. Everyone on board was lost. Even after that tragedy, the planes kept flying. 5 months later, Ethiopian Airlines Flight 302 suffered the exact same fate. 346 lives were gone, not because of a storm or an engine explosion, but because of a line of code and a sensor that failed. The global fleet was grounded. The financial cost to Boeing was tens of billions of dollars. But the human cost is immeasurable. When the investigations began, the world didn't just look at the sensors, they looked at the culture. They looked at the emails where employees joked about Jedi mind-tricking regulators. They looked at the moments where the engineering mindset, which should be obsessed with safety, was overruled by the business mindset, which was obsessed with the bottom line. This story forces us to ask a difficult question. What is an engineer's true job? Is it to build a machine that works, or is it to be the final gatekeeper for human safety? In many parts of the world, when an engineer graduates, they receive a ring, sometimes made of stainless steel, sometimes of iron. In Canada, legend says the original rings were made from the wreckage of a bridge that collapsed due to poor design. It's worn on the pinky finger of the working hand, so that every time an engineer signs a blueprint or types a line of code, they feel the metal against the paper. It is a physical reminder that their mistakes have consequences. Engineering is a position of immense power. You are designing the world that other people have to live in. Whether you're building a bridge, an algorithm, or a commercial airliner, you are holding lives in your hands. The lesson of the 737 MAX isn't that technology is dangerous. It's that technology is human. Systems don't fail in a vacuum, they fail because of 1,000 tiny concessions made in air-conditioned offices long before the plane ever leaves the tarmac. When the pressure is high and the deadline is looming, the most important tool an engineer has isn't a calculator or a computer. It's their voice. The courage to speak up when something feels wrong is just as vital as the ability to solve a complex equation. We live in a world built on the brilliance of engineering. We fly through the clouds, we cross massive canyons, and we communicate across oceans because of it. But that progress is only possible because of a silent contract between the builder and the user. A plane is more than just wings and engines. It is a promise. A promise that safety will always come before speed, and that ethics will always come before profit. Because in the end, an engineer's greatest achievement isn't a machine that flies, it's the trust of the people inside it. That trust is a silent contract, written in every bolt, every line of code, and every signature. The story of the 737 MAX, MCAS, reminds us that while technology may be complex, our responsibility is simple. Never let the pressure to succeed outweigh the duty to protect. Because when we lose that balance, we lose more than just a reputation. Engineering is about more than just building, it's about having the courage to stand up for the truth. Every single time,